the constant development of new radiopharmaceuticals, the field of nuclear medicine and molecular imaging are continuously evolving in our journey towards real personalized medicine.
Most exciting to work with PET imaging is to develop new radio tracers because it can improve cancer therapy and therapeutic outcomes.
The PET center in Tromsø allows us to do all the work in the tracer development under the same roof. And that's, I think, is very special.
The PET imaging center in Tromsø is the northernmost PET imaging center in the world, as far as I believe. Located beyond the Arctic Circle, we are physically connected to the hospital and also physically connected to the university. We in Tromsø can do research from basic organic chemistry all the way to research in human beings. In the basement we have a cyclotron, equipment for producing radiopharmaceuticals. On the ground floor we have clinical scanners for patient examinations. At the first floor we have facilities for preclinical studies. The PET Imaging Center in Tromsø was opened in 2018 by the Prime Minister Erna Solberg and the philanthropist Trond Mohn. Recently, Trond Mohn has financed a research project called 180 Degrees North. That is a collaboration between Bergen, Trondheim and Tromsø. 3 locations cooperate together to do proper research in tracer development, in preclinical studies and also clinical studies. Because we have such nice facilities for preclinical studies, we would like to focus more in that field.
The Cyclotron and Radiochemistry Lab R&D facilities deliver radiopharmaceuticals to the clinical imaging area and to the preclinical research area. In our facilities we have a cyclotron with targets for the production of different radionuclides that will be sent to different hot cells by using a target switch system. We have automatic radiosynthetic modules. We have also a very interesting analytical park, including a high-resolution mass spectrometry instrument.
The preclinical facility in Tromsø is located in the PET Imaging Center.
We have acquired a comprehensive range of systems for in vitro testing and dedicated labs for cells and tissue work.
Following successful radiochemistry and in vitro testings, we also have to show that these mechanisms work in vivo as well. Therefore, we are using animal models of brain cancer.
Our area here is located inside the animal barrier, very tightly connected to the animal house at the university. This is very relevant to, for example, follow the same animal during long term on the same conditions.
We have acquired the latest technology in small animal nuclear imaging, and that includes PET, SPECT, CT and MR.
Our small animal PET-MR combines a 7 Tesla MR scanner with a whole body mouse and rat PET.
This X-ray irradiator is a state-of-the-art image-guided irradiator for small animals, the first of its kind in Norway and one of few in Europe.
Radiopharmaceutical chemistry allows us to watch physiological and pathophysiological processes in a very selective and specific way.
We run static PET and SPECT, but we also run dynamic PET, and this allows us to also quantify the amount of radioactivity that we find in the different organs.
At the moment, we are developing radiopharmaceuticals for application in brain and lung cancer, immune system imaging, and also for CNS drug discovery and development.
Besides applying radioisotopes for imaging only, here at the PET Center in Tromsø, we aim for treat and image brain tumors at the same time. This approach is called theranostic.
In this effort, we are pursuing the development of new radiopharmaceuticals based on true theranostic pairs. We are working with copper-64, copper-67.
We are now in the phase to test them in vitro on cells and on brain slices, going over to in vivo testing in animal models of brain cancer. And we hope that we can go really soon, within the next years, to clinical application.
Preclinical radiation biology is a cornerstone in frontline translational cancer research. In one of our ongoing projects, we combine preclinical irradiator technology with preclinical PET technology. We develop novel radio tracers that specifically target immune cells so we can perform PET-based immune imaging. This allows us to track immune cells in vivo in response to therapy.
For patients with cancer in their thyroid, for patients with neuroendocrine tumors, we already are using the concept of theranostic. Here in Tromsø, we are focusing on brain tumor, and hopefully one day we will see the theranostic concept used also for these patients.